Hi Math 30s. This video is going to be part 1 of lesson 2 in permutations and combinations, and it's on page 381 of your workbook. Where we start is looking at an example that we looked at in lesson number 1, and it says, consider how many ways are there of arranging 6 different books side by side on a shelf. So what we looked at in lesson number 1 was something called the fundamental counting principle, and it says that in order to figure out the number of ways to complete a task, you break that task up into stages. So if there's 6 different books, that could be represented by 6 stages. So you have 6 books laying on your table. How many of those books can go into this first spot on your bookshelf? If there's 6 on your table, there's 6 possible books that could go there. Once you place a book, there'd be 5 books that can go into that spot, then 4, 3, 2, 1. And the fundamental counting principle said that the number of ways to complete the task is by multiplying the number of choices in each stage. So when we multiplied these numbers together, we got 720 different ways of arranging 6 different books side by side on a shelf. Now, this is called a descending sequence, right? So descending 6 down to 1. We actually have in math a shorthand way of writing a descending sequence. So how I could represent this is in something called factorial notation. And what that would be this, 6 factorial. So it looks like 6 exclamation mark, but that means factorial. So we do have this button on our calculator. So take out your calculators, type in 6, go to math, and scroll over to probability. So the factorial button is number 4. What this button will do is it will descend the numbers 6 times 5 times 4 all the way down to 1, and will give us 720. So why do we want a shorthand sequence? Like, why do we want a shorthand way to notate? And it's because I could give you the question, how many different ways are there arranging 10 books on a shelf? So you could, on your calculator, type in 10 times 9 times 8 all the way down to 1, or you could just go to 10 and then the factorial, and it will multiply that descending sequence for you and give you 300,628,800 different ways of arranging 10 books. It says, without a calculator, determine the value of 4 factorial. So 4 factorial is simply 4 times 3 times 2 times 1. 4 times 3 is 12, and 12 times 2 is 24. If we were to evaluate 3 factorial times 2 factorial, well, 3 factorial would be 3 times 2 times 1 times 2 factorial would be 2 times 1. 3 times 2 times 1 would give you 6 times 2 would be 12. What I want you to write here is there's actually going to be different ways that I could represent 6 factorial. So we know, according to the fundamental counting principle, that's going to be 6 times 5 times 4, 3, 2, and 1. And that's going to give us 720 different ways. The other way, though, or another way that I could represent 6 factorial would be as follows. 6 factorial is equal to 6 times 5 times 4 times 3. If I want to stop here, I have to put factorial. If you type this in your calculator, 6 times 5 times 4 times 3 factorial, you are going to get 720. Why would you get 720? It has to do with 3 factorial is the same as 3 times 2 times 1. So that would be the exact same thing, 6, 5, 4, 3, 2, 1, as this. Here's another way of writing 6 factorial. 6 factorial is going to be the same thing. I could say as, represent that as 6 times 5 times 4 factorial. That will give you an answer of 720. Again, the reason is 4 factorial is 4 times 3 times 2 times 1. So this descending sequence, 6 times 5 times 4 times 3 times 2 times 1, is 720. Okay. Another way that I could represent it would be 6 factorial is equal to 6 times 5 factorial. If you typed in 6 times 5 factorial on your calculator, again, you will get 720 because I could reduce 5 factorial. There's going to be ways that we could solve something like this in our heads or without using a calculator. And it's a method that I call unzipping. And what you want to do in order to unzip is you want to look at the two factorials, numerator and denominator, and you want to unzip what is bigger. So between these two, it's going to be the 6 factorial that's bigger. You want to unzip, so again, unzipping is like 6, 5, 4, right? Writing a descending sequence, and you want to unzip until you get to this to match. So here's what I mean. 6 factorial could be written as 6 times 5 times 4 factorial. And then I've got 4 factorial in the denominator, and 4 factorial and 4 factorial will cancel. I'm left with 6 times 5, which is 30. Okay, let's look at this one. Express 5 factorial as a product in 4 different ways. So we know that 5 factorial, if you unzip that, is 5 times 4 times 3 times 2 times 1. Or if I don't want to go all the way down, 5 factorial is the same thing as 5 times 4 times 3 times 2. If I want to stop here, I put the factorial. Because remember, what is 2 factorial? It's 2 times 1. Another way to write 5 factorial, to express 5 factorial, is 5 times 4 times 3 factorial. Because, once again, 3 factorial could be unzipped to 3 times 2 times 1. And the last way that I could represent 5 factorial as a product is 5 times 4. Now I can't stop at 5 times 4 because that would be 20. I have to put that factorial sign to represent the 4 that gets to be unzipped. So 4 times 3 times 2 times 1. Without using a calculator, simplify. So again, we've got a factorial in the numerator and denominator. Unzip whichever factorial is the larger one, which would be the 10, and you want to stop when you're going to get a 7 factorial because we want to cancel. So 10 factorial is 10 times 9 times 8 times 7. If I want to stop, I must put the factorial all over. The denominator has the 7 factorial. You could cancel those terms, and you were left with 10 times 9 times 8. How you do that in your head probably is 9 times 8 is 72, and 72 times 10 is 720. Look at the second one. If we were to do this without a calculator, you would unzip the numerator because that's the bigger factorial. You're going to stop when you get 5 factorial. So unzipping 8 factorial would give me 8 times 7 times 6 times 5 factorial. In my denominator, I have the 5 factorial, and I have 3 factorial, which is simply 3 times 2 times 1. Cancel where you're able to cancel. 5 factorial will cancel with 5 factorial. And there's something else that could actually cancel. 3 times 2 times 1 is 6. So I've got 6 in the denominator, 6 in the numerator. That would also cancel. 6 cancels with 6. I'd be left with 8 times 7, and 8 times 7 is 56. I'm going to show you a diploma question and what a question on an exam could look like that we would combine the fundamental counting principle with factorials. So here's what the question that students had a few years ago. It said, if all of the letters in the word diploma are used, then how many different arrangements are possible that begin and end with an I, O, or A? So first we need to figure out how many stages we would have in this task. So you count up the number of letters in the word diploma, and there are 7 of them. So that would give us 7 stages. They are giving us a restriction And it is how many different arrangements can we make that start and end, so the first stage and the last stage are going to be an I, O, or A. So the first stage, I've got a choice between an I, O, or A, and the last stage, I, O, or A. So in this first stage, I have 3 letters to choose from that could possibly go in that first stage. Then I go to my last stage, and if I've placed one of those 3 letters here, that leaves me with 2 remaining letters to choose from to go there. How many letters did you just place? So we've placed one here and one here. We've placed 2 letters. So from the 7 letters in the word diploma, I've just placed 2 of them. I've got 5 letters left over. So how many letters do you have to choose from to go in this stage? 5. Then you're going to have 4, 3, 2, and 1. Multiply the number of choices in each stage together, and you're going to get your answer with the number of arrangements. This was actually the multiple choice question, and here were the different solutions that they had. So none of them right now match this. So what you need to realize is 5 times 4 times 3 times 2 times 1 could be written as 5 factorial. And then I've got that times 2 at the end and times 3 at the beginning, which would give me D as an answer. Okay, let's look at factorial notation, and we're going to figure out a general way that we could write a number in factorial notation in a general way. So here's what I mean. If I said 8 factorial, okay, so what does 8 factorial equal? Well, we know we start with whatever number that is, so 8, and then we start unzipping. 8 times 7 times 6 times 5 times, and we're eventually going to get to 3 times 2 times 1. If I said, how could we write this in a general way? So instead of having 8, I'm going to choose any number. What would the general way to express this be? Well, whatever, we had 8 here and 8 here, so whatever number this is, we're going to start with that. Then, how do you get 7? Well, it's 8 minus 1, right? That's how you would get 7, so that would be n minus 1. How do you get 6? Well, that would be 8 minus 2, so n minus 2. And then it's going to be n minus 3. And it will keep descending until eventually you're going to get a 3 times 2 times 1. This is the general way that we could express factorial notation. And it says where n belongs to the element of, there's actually a mistake here, it should be n belongs to the element of natural numbers, because we descend until we get, remember the natural numbers are kids counting numbers, and kids when they start counting, they start at 1, right? So what that means is when we are writing our descending sequence, we stop at 1, we don't stop at 0, and we'll have no negatives, okay? And the reason why we can't stop at 0 is because if I multiplied this descending sequence and I had a 0 in there, the entire thing would be equal to 0. So let's use this general form and look through this first class example. So it says complete the following. How could I represent n factorial? Well, we know if I just said n factorial, that's going to be n, and then n minus 1, and then n minus 2, on and on until we get to 3 times 2 times 1. Well, what they're doing is they're breaking it down, but they actually want to stop at n minus 1. So remember, wherever you stop, you must put a factorial sign if you're stopping. If you're not unzipping right down to 1, you've got to put a factorial sign there. So if I unzip n factorial, I'm going to have n and then n minus 1. So we're missing an n here. N plus 2. So again, if you're just given n plus 2 factorial, and you're told to unzip that, you start with n, which in this case is n plus 2, and then each one is going to be one number less, right? So n plus 2 minus 1 would be n plus 1. And then next, it would be minus another number, which would just give me n. And then next, n minus 1. and then n minus 2. And if I want to stop, wherever you stop, you've got to put that factorial sign. So if I look, n plus 2, they want to stop at the n. They want you to put the factorial sign right here. So what that means, if I stop there, well, what did I have? I had n plus 2 and n plus 1 and then n. And then times n factorial. If you saw this descending sequence, what would have been the original factorial that they gave you? And that would have been n minus 4. So n minus 4 factorial. And if you don't really understand that, like, well, what do you mean that we would get this answer? So if I gave you n minus 4 factorial, and I said, okay, start unzipping that, you always start with your n. So this case would be n minus 4. And then the next one, it's always one number less. So if I subtract 1, that's going to be n minus 5, n minus 6, and we keep going until we get 3 times 2 times 1. Or if I wanted to stop here at n minus 6, I have got to put the factorial sign. Okay, so how are we going to apply this? We're going to apply it with questions at class examples 2 and 3. So it says simplify the following expressions, leave the answer in product form where appropriate. So this is going to be the unzipping, right? We're going to unzip and we're going to try to cancel. How you tell which one you're going to unzip is you ask yourself, if I pick a number for n, so let's say I select n is equal to 10, whichever would give you the larger number, that's the one you unzip. So 10 plus 2 would be 12 factorial. This would be 10 factorial. This is what we're going to unzip. You stop when you get to an n factorial, because then we could cancel. So n plus 2 factorial, right? N plus 2 factorial. If I said, how could you express that? Well, you know that that would be n plus 2, and then one number less. That would be n plus 1, one number less. That would be n. I want to stop. I've got to put the factorial. I had that n factorial in the denominator. You cancel, and you're going to be left with n plus 2 and n plus 1. Let's look at B. Which of these two is larger if I put a 10 in for n? So I'd have 8 and I would have 9. This denominator is larger. This is the one you unzip. You stop when you could cancel. So what do I want to cancel it with? An n minus 2 factorial. Okay, so how do you unzip n minus 1 factorial? How would you do that? So it's going to be n minus 1. And then the next one is 1 less, which would be n minus 2. I want to stop now. I've got to put the factorial to stop. In the numerator, I had n minus 2 factorial. This would cancel, and I'd be left with 1 over n minus 1. When you get to C, there is only one that you could unzip, and that's going to be the numerator. You could only unzip something if it has a factorial sign. So if you were to unzip n factorial, and we want to cancel, right? I want to cancel, I want to have n with an n minus 1 with n minus 1. So let's unzip this. N factorial is equal to n. Then it's equal to n minus 1. Then I cannot stop here, because if I stop here, I need to put a factorial, right? In my denominator, I've got the n and the n minus 1. Right now, I could cancel these n's, but I am unable to cancel numerator and denominator here because this does not have a factorial. So I cannot stop with this one. So n minus 1. The next one would be n minus 2. Now I'm going to stop, put my factorial, and now I could cancel n minus 1 and n minus 1. And what I am left with is n minus 2 factorial. Let's look at class example number 3. Algebraically solve this equation. So right now, just ignore this equals 42 and look at um, these two, numerator and denominator. Which one would you unzip? So it's always the larger one. So 10 factorial versus 8 factorial, so it's going to be the numerator. Where do we stop? The idea is you always want to cancel. So we're going to stop when I could cancel with an n minus 2 factorial. Okay? So what will this look like? Okay, n factorial. I could represent that as n times n minus 1 times n minus 2. If I want to stop, stop by placing your factorial. My denominator has an n minus 2 factorial. This, they say, is equal to 42. You could now cancel n minus 2 factorial with n minus 2 factorial. What we would be left with is n times n minus 1 is equal to 42. Because it says solve, we're going to be solving for n. So in order to do that, you need to distribute your n squared minus 1n equals 42. And we're going to solve by factoring. So bring everything to the left-hand side. And you are looking for the two numbers that multiply to negative 42 and sum to negative 1. So those two numbers would be 6 and negative 7. So again, remember, don't drop your 0 here. And then we're going to solve for n. So if you set each factor equal to 0 and you solved, you would get n is equal to negative 6. And here you'd get n is equal to 7. And only one of these is actually the solution. One of these we have to reject. The solution is going to be n is equal to 7. N minus 6 we would reject. And the reason why we would reject is because n must belong to the element of the natural numbers. So n cannot be a negative number. It cannot be 0. How you would check your answer. So we're getting n is equal to 7. So let's see how we could check that we did this correctly. You're going to go to your original equation, and where we see n, we're going to take n out, and we're going to put in a 7. So that would give me 7 factorial over 7 minus 2 factorial. 7 factorial over 7 minus 2 is 5 factorial. If I said simplify this, you would unzip the numerator because it's larger, and you would say that that is 7 times 6 times 5 factorial. In your denominator, you have a 5 factorial. 5 factorial over 5 factorial would cancel, and you have you have 7 times 6, which is equal to 42. And that is what we had on the right-hand side. So our solution of n is equal to 7 is correct. Okay, this is just explaining how to use the factorial button on your calculator. Let's do a couple of things before we do the homework. So let's calculate the value of this. We could punch this into our calculator, or I could unzip to simplify. So I'm going to unzip the 43 to get 43 times 42 times 41 times 40. If I want to stop, because I'm not going all the way down to 1, put your factorial over 40 factorial. That will cancel. And then you could type in on your calculator 43 times 42 times 41, and you will get 74,046. You could do the same method here, or on your calculator you could simply type in 37 factorial, divide, and then make sure for the denominator here, you put that in a bracket. So 33 factorial times 4 factorial. I want you to punch that in and see what you get, because the answer should be 66,045. here's the homework that I want you to do. So 1, 2, 4, 5 ABC, 6 ABC. I'm going to I'll do 6A with you, and then I'm going to set up 6B. You might not know how to start that one, so we'll look at that one together. So let's flip to page 386. So again, for 5, if we were to look at this, simplify the following, n factorial. That's the one that could be unzipped, right? So what is n factorial equal to? It is equal to n, and then n minus 1, all over, I had a denominator of n. This would cancel, and what you would be left with is n minus 1 factorial. For these two, figure out which would give you the greater number if n was 10. So you'd have 7 factorial and 8 factorial. So you're going to start unzipping n minus 2 factorial until you could match and cancel out an n minus 3 factorial. Okay, so see if you're able to do those. Let's look at 6a, solve the equation. So we're just going to look at the left-hand side to begin with. Again, I need to unzip one of them. And this would give me, if I have a n is equal to 10, that would give me 11. This would give me 10. I'm going to unzip the numerator. I'm going to unzip until I get to an n factorial. So n plus 1 factorial is going to be n plus 1. And then that's going to be take away 1 would be n. And I'm going to stop factorial. My denominator has n factorial. And this, they said, is equal to 6. N factorial over n factorial will cancel. And I'm going to now be left with n plus 1 is equal to 6. Solve means we need to isolate our n. There's no factoring here. There's no inspection or decomposition. So n is equal to 5. And then just so that you're understanding this, you should verify, right? If n is 5, that would be 5 plus 1. So that would be 6 factorial over 5 factorial. If you unzip this, it would be 6 times 5 factorial over 5 factorial. And this would cancel, and you'd be left with 6, which is what they have on the right-hand side. For B, you want to unzip in order to cancel, right? But we can't actually cancel in this example unless we have all factorials together, right, on one side of your equation. So bring this n minus 1 factorial over here. So divide this guy by n minus 1 factorial. Divide over here by n minus 1 factorial. And then what we would have is we would have n plus 1 factorial over n minus 1 factorial is equal to 6. Now you could start unzipping, and we'd unzip the larger, which would be the numerator. So if I unzipped n plus 1 factorial, I would get n plus 1, and then I would take away 1, that would give you n. Take away 1 again would give you n minus 1 factorial, n minus 1 factorial, and you would cancel. And then from here, let's distribute in the n to give us n squared plus 1n is equal to 6. Bring that 6 to the left-hand side, and you'd have n squared plus 1n minus 6 is equal to 0. And then you want to factor that by inspection. Remember, you're going to get two solutions. One solution you're going to reject. The other one's going to be your solution, and you should double check. So whatever number you get, put it back into your equation and make sure that the left-hand side equals the right-hand side.